Welcome to Launch One with Mason Springer. I'm Mason Springer. Today we're joined by Eric Newman of P&L Testers. Eric is a pretty cool guy. I remember the first time we talked on the phone, Eric. We met through our mutual friend Brian Tanner, and he introduced us over text. And we had a phone call. Our first phone call was like an hour and 40 minutes long. I mean, we talked forever. I thought that was really good. I mean, we had a lot to talk about, and I still got plenty to talk to you about. But yeah, thanks for joining me today, Eric.
Oh, you bet. Anytime.
Yeah. So P&L Testers, that's kind of your brand. I remember, you got your website and you got some data and good information out on that. But what does P&L Testers stand for?
P&L Tester stands for Physics Never Lies. So
Perfect.
I did that a few years back. Yeah, I actually had I actually started out with Physics Never Lies, but bow hunters do. But that one caused a little bit of an issue, so I removed the bow hunters do. So that was
Yeah.
a little different. Yeah.
Yeah. So, I mean, over, we've had a couple real good conversations. I mean, I've learned a ton from you about, data, especially data, the science, the physics, like you're talking about. I mean, as far as I know, you know your stuff and have done plenty of testing. But I mean, how'd you get started into doing all this testing and high level numbers and data and stuff in archery?
The physics side is years ago, like everybody, I made a mistake. Made a bad shot, blamed my equipment, said to myself, and I went to researching. I found Dr. Ed Ashby, did a lot of research, opened up a big can of Kool-Aid, jumped right into the bottom. Went to really studying, researching all of that. Then I met a guy over in Archery Talk, went by Ugly Joe. His name is Jared Spencer, PhD. He's the one that got me into physics. So from that point on, I just went really hard, deep into physics. Met some other people, Joel Maxfield, David Holt, stuff like that, and then I just got into testing. So I built a lot of test equipment to test, and we're just keep moving forward with that.
Yeah. Yeah.
hmm
So like, tell me about some of the equipment they use to test. I know you've got a pretty nice shooting machine.
The shooting machine is, I started out like everybody else that were doing that. I was using a Hooter shooter, but it didn't take very long to realize that the Hooter shooter is just, it's okay. So I built a shooting machine. I built one with a linear guide. It's fully PLC operated. Once I set the bow on it, I set a few limits on it, and from that point on, I just hit a start button. I can control the rate of speed. Once I hit the back, I can control a time delay, and then it just fires. And then it's ready to go back home and ready to do it again. So there's quite a bit I can do with the machine. Anything in flight I can test. I can test strings where you got string manufacturers that are claiming that their strings are gained in 4, 5, 6 feet per second. I can actually test all of that, and I don't do it with mainly velocity. I'm looking at the bow. So I'm looking at what's called mechanical efficiency of a bow. I'll measure the draw curve, take that data, then I'll shoot the arrows, and then I'll collect the kinetic energy. And then with math, you just take it and calculate the efficiency of a bow, and then you'll put the strings from the other manufacturers, put it on there, and do the exact same thing. What you're looking for is the bow truly gaining. Speed's not really, 2, 3 feet's okay, but to truly see if a bow's doing anything, you need to look at the dynamic or mechanical efficiency of the bow. That's what should be done. I doubt if anybody's really doing that other than manufacturers, but I do that. Part of that is my data set. People that do look at draw curves, they are usually measuring every 1 inch. So like on a 20-inch power stroke, they're going to take 20 measurements. I'm taking 3,000. So yes. So there's a big difference in quality of data there. I do a lot of spine testing, looking at an arrow. A lot of times when I'm doing spine, a lot of people will just set their indicator and pull and check one reading. If I'm in a hurry, I take 4. If I've got a little bit of time, I take 8. So I'm reading, a minimum of 90 degrees all the way around, but I like to try to do it, every 45 degrees. And I can plot an arrow and I can show you what the arrow actually looks like. I got testers for testing edge sharpness using that same BESS material that a lot of people use. You'll see that a lot of them are using a tester called a PT, I think it's a PT50. There's 3 models. The best one it takes about 25 readings per second, so it's rating at 25 hertz. I'm testing anywhere from on the low end at 50 up to about 125 times per second. It gives you a better look at things, is what it does. You know, you don't miss points. At 25 hertz, you can actually miss the peaks. At about 125 hertz, you don't miss peaks. So
Yeah.
it makes a big difference in equipment, but it does cost money to do that.
Yeah.
So
Yeah. Wow. So that's a lot. So it sounds like you've got some of the better equipment out there. I mean, especially going back to the shooting machine that you've built, like, explain to me, like, how exactly is that better? You've got it all automated. How does that compare to other machines that are out there in the industry? And I guess what makes yours different from other ones I may have seen?
So if you look at the Easton, the one they did, that one's is all controlled by air. So I'm sure they can control the speed, but they pull a lever, pulls the air cylinder, and then he's reaching up there and he's manually pulling a string to fire. Mine's all hands off. Mine is controlled by a stepper motor, so that's where I can control the speed. Once I hit the back, it's all automatic fire. So nothing is being touched once I start. That's probably the biggest difference. I'm very sure that there's some machines out there that we haven't seen, that manufacturers don't let us see, that are going to be doing the exact same thing, if not better. But on average, no one's got one like I got.
Yeah.
So,
Yeah. That's impressive. I've done some, a little bit of stuff. I've got a hooter shooter, and like you said before, there's only so much you can do with one. But I've spent hours trying to get that thing to be consistent. I've bolted it down to all kinds of stuff, put hundreds of pounds of weight on it, trying to keep it from moving, and just doing all kinds of crazy stuff trying to get it good. And then I'll get it shooting good maybe for a dozen shots, and then after that it's all over the place again. So it's kind of inconsistent there, but having a nice machine like that is definitely what you need when you're doing testing at that level. So another thing you said earlier, and we had talked about this in a conversation a week or two ago, is the mechanical efficiency of a bow. So that's something that I kind of heard about for the first time. It's probably been 3 years now. I think I was at the Hoyt booth at the Lancaster Archery Classic. And between Hoyt, Matthews, a couple different manufacturers I remember there. And I'd heard one of them say something about that. So then I started asking everybody, what is mechanical efficiency? What's it do? And I learned a couple of things. But then I learned a lot more talking to you the other day. So what exactly is mechanical efficiency in terms of compound bow?
What you're looking at is you're looking at a draw curve, and once you calculate, you're trying to see how much energy is transferred to the arrow, and then you'll see what is wasted. Manufacturers test it typical at 30 inches, 70 pounds with a 350 grain arrow. And what they'll do is they're looking at how much energy is actually transferred. A good bow is about 85%. So you got, what's that, 15% that's wasted into noise, vibration, and whatever. So that's what we're looking for. Matthews probably runs high 86, low 87%. So the advantage of understanding that is when you're testing, and I don't really know why people don't test this. When you're looking at a bow, the velocity or feet per second is not everything of the bow. I mean, for the average person, yes, they only care about how fast it is, and the faster the better. But a really efficient bow, you won't see much of a gain going from, say, a 350 to a 550 or even a 650 grain arrow. You'll see maybe 4% gain in kinetic energy. So that's what you're looking at. You measure kinetic energy. A bow that doesn't have much efficiency gain like that is good. That means it's not wasting as much energy with a light arrow. And that's what you want to look for, especially for people that like to shoot in the 400 grain range. A bow that you're shooting a 350 and you shoot a 650 and you're seeing a 7% gain, and I've seen some with a little higher, that bow is gaining in efficient, but that bow is not an efficient bow at all. At all. Once you get above probably 4.5%, 5% gain, you are becoming non-efficient. and that's what you don't look for. Most bows are still 85%. Most manufacturers or some of the ones I've talked to, they're happy at 85%. Like I said, Matthews isn't. Matthews pushes the envelope pretty hard. So I'm sure that's
Yeah.
part of the reason Matthew bows are a little finicky sometimes, and people fuss about that. But they're putting everything they can out of that bow.
Yeah, yeah, that's
Hmm.
something I haven't heard before. So um, that 85%, I've heard that number bounce around a little bit, and you talk about some manufacturer a little bit higher, a little bit lower. How does that? As far as I've heard, that's one of the like a Matthews compound bow is one of the most like efficient mechanical systems in any industry. Is that somewhat accurate?
Probably so. Probably so. I don't remember the dates. It hasn't been. I'm gonna say that many years, but it's probably been 15 to 20 years. When a bow first, was getting 82%. Everybody was happy. To push where we're at now at even 85%, it took a lot. A lot of people look at that and they think, well, from 82 to 85%, that's nothing. Well, actually, that's a lot for a bow. A lot. It's very, very hard. Once you get in that 85%, it's very hard to push that envelope even higher. Um, I doubt if we'll ever reach 90%. Not at the IBO rating. Mm-mm. I don't know. If to do that, they're going to have to make a major change. Something to do with either your limbs, your cams. They're going to have to make a big change. So hopefully
Really?
one day, but I doubt it. Not in my lifetime anyway.
Yeah, yeah. So
Mm-mm.
what's the practical application, or I guess the practicality of having a bow that's 85% efficient versus an 80% efficient? Like, does that result in more speed? What's that do?
No, it doesn't always mean mill speed. You can take a speed bow, like some of your old PSEs that were just screamers, and their efficiency wasn't very good. So efficiency and speed doesn't really correlate together. It's more of just how much you're getting transferred to the arrow and less wasted energy. You don't want to waste a bunch of energy if you're got a lot of vibration. Bows that's got a lot of vibration, their efficiencies are usually 83, 84, 80, they're right in that range. They might even touch 85, but most of them at 85 you don't feel the vibration, and that's what they're doing. It's just wasted energy. Anything get below 80, 85%, you're just wasting too much energy. And there are bows out there that are in there. Um, my APA, I had an APA M5 years ago. Yeah, that bow was an extremely inefficient bow. It liked heavy arrows. So it would probably run around 82% with a light arrow. But you could push, get up there, go from a 350 to, 650, 700. And I guess we're going to have to pause. I got to turn the light on.
That's all good.
Oh, I got a
I
motion
guess.
light. I forgot about it. So that bow wasn't very efficient, but it loved heavy arrows. So it really came alive with a heavy arrow. But it had a lot of vibration. I did a lot of crazy things with that bow. I shot that bow at 70 pounds. I'm a 26.5 inch draw, but I tested arrows with that bow all the way down to 250 grains. People freak out and they go, as long as you can keep a bow roughly 80% efficient, you're not going to break it. You want to keep the nuts and bolts all still tight, but on general, good set of limbs, they won't break. Or I've never
Really?
broke them, and I shot a lot of arrows that light out of that bow. Hmm.
Yeah, yeah.
Hmm.
So what's the correlation between efficiency and arrow weight? I know you said lighter arrows make it less efficient, heavier is more efficient.
Yes. You're always going to gain when you add mass. You'll hear people say that you add mass and your KE will drop. If people are measuring that, they go out there and they'll start in. If you ever see a dip, so let's say and I'm going to just make an arbitrary number. Let's say we're running at 75 with a low arrow, 350 grain. 75, we bump up and we go to 76 and we go to 77. Then you'll see one that somebody will drop down and go back to 76, and then they'll go back up. That dip is them. That's not the bow. A bow will always climb. It may not have a big climb. You may reach a point where you're at 77.5, then you'll go to 77.6, 77.7, but it should never dip. Usually that is just a change in how you shoot. I never shoot through a chronograph if I'm collecting data off the hand. Never. Because you'll see that and it messes with people and they don't understand. But you should always see a climb. It should never decrease. Is that what you're trying to get to? So,
Yeah,
yeah, yeah, it should always climb. And like I said, when I'm shooting a bow, it depends on what I'm looking for. Um, I like a bow that whatever my KE is at 350 grain arrow, if I hit 650, if I ain't got more than about 4% gain, I'm happy. That means I'm getting everything out of that bow, even with the 350 versus the 650. And that's what I'm looking for. Bows that are going to go from, you know, whatever KE at 350 and they gain 6-7%. Yeah, I'm gaining, but I'm losing a lot at the low end because my average arrow is probably 380 to 410 grain. So I want as much energy or as much transfer as I can with a lighter arrow.
Yeah. So
Mm-hmm.
are these manufacturers, are they building their bows to be more efficient with a certain arrow weight, or is that just inherently how these systems work?
Most all testing is done at IBO/ATA or yeah, IBO. It's 70 pounds, 30 inches with a 350 grain arrow. Now, I say 350, it's 5 grains per pound. So if they're testing a bow at 60 pounds, the arrow should be at 300 grains. But that's where everything is tested, and everything is based off of that for their mechanical efficiency test. So, because you will see a gain, it wouldn't be fair for me to come in and test this bow with a 350 grain arrow and then test this one with a 650 and tell you, see, my bow's 86% and yours is only 84. So there are standards, but nobody's policing it. So I don't know. Nobody's really forcing anybody to do things.
Yeah, yeah.
So
Which you say that now, and there's a lot of YouTubers coming out and kind of going through, and I know MFJJ's been big on this last couple of years. If he'll always test the speeds of bows, and and make sure that they add up to the manufacturer's specs, which I know that's kind of been a big thing the last several years, and supposedly manufacturers have been a little bit better about making sure their numbers are accurate. Does that seem like a trend you've been seeing?
they're definitely doing that. We got better materials. People are spending a little more time. They're more cautious of what's going on. You still got manufacturers out there that are running 10, 15 feet below IBL reading. It just happens. Some of that testing, though, is there's some influencers out there that they're fantastic guys. But anytime that I see somebody shoot an arrow through a chronograph and I'm seeing they shoot 3 times and I'm seeing arrows with a 3, 5, 6 feet per second difference in between them 3 shots, I move on. When I'm testing and I'm providing data, and because I do data for manufacturers, my deviation better be less than zero point 0.5. I actually want a deviation down there at about 0.3. If I'm getting anything in my deviation of 0.8, then I stop. I go to looking to see what's going on because something's not correct. You should never see an influencer that's really trying to show good data. If he's seeing more than 1 foot per second, that's him. It ain't the chronograph. That is him. Most generally what happens is they're moving back and forth just a little bit. They're pulling a little harder into the wall or not quite as hard, or they're not even shooting through the same spot in the chronograph. And that varies everything. I try to follow the ATA technical guideline or ASTMs. So when you're doing that for checking speed, first off, you're supposed to shoot 5 times. Your chronograph is supposed to be a photo eye type. It cannot be like the Garmin's, any of them type that radar. You're not even supposed to use any of them. They have to be a photo eye. It has to be the type with a minimum of 2 photo eyes. So there are some chronographs that only use one. There's actually specifics that you're supposed to follow, and that's what I do. The chronograph I use is called an Oler 35P. That is the ballistics. The ballistics consider that one the gold standard. It uses 3 pickups. I have the primary. There's it checks the primary, and then there's your complete. So these first and the second one are 4 foot apart, and then this one is just a verifier. So if it's very far off, it'll flash at you. It'll let you know you made a bad shot. So if you don't shoot through the windows correctly, this one will tell you that. So I try to keep my data as tight as possible. Is it really needed? Probably not. General public, that's probably more than they need, but I'm just, anal when it comes to producing data. So
Yeah. Yeah, well, I mean that's definitely not a bad thing. That's you're definitely the only one. I mean, the only chronographs I've ever seen used for archery is like the the old Pro Chronos, I think they're
Hmm.
called, and then the Garmin's and the lab radars and stuff like that. But yeah, bringing a real, I guess, ballistics,
Hmm.
that's big. So, tell me about how so you're testing the speeds of these bows. What's the relationship between if you got a bow that's 85% efficient and it's transmitting 85% of that power into the arrow, what's going to be the difference in output? Is that measured in kinetic energy, I guess? How are you measuring the output?
Well, I still do everything like everybody else. I'm still measuring feet per second. You know, that measurement's actually is their first pickup is supposed to be 36 inches plus or minus 1 inch from the pocket of the grip. So from that point, then you just calculate your kinetic energy and then use that for all your equations. Um, does it does the efficiency on speed? I'll tell you, there are bows out there that are running at 85% efficient that are way faster than bows at 87%. So speed doesn't quite correlate to that efficiency. It all you can see that in the draw curve. Um, Bows that are really hard, that come up fast, stay with a long dwell, and then drop off real quick at the back on the draw curve. You're going to get some speed out of them. The ones that are slow, that are real easy pull up or got a lazy back on the draw curve, you just that's what they're for. They're for a smooth, easy draw. You're just not going to get the speed out of them. Okay, but that doesn't mean that the efficiency is not good. It still
Mm-hmm.
could have a good efficiency. It's just the speeds that are not there. Like I said, you got my Omen. I got an Omen with a S2 cam. That bow's fast. For my draw length, it is screaming fast. It's extremely hard to draw. Um, its efficiency's running, I don't know, it's probably right around in with the Matthews on that one. They did a real good job with that S2 cam. They should have kept it. But it's way faster. But if you look at the draw curve, you can see why. It's
Yeah.
pretty harsh. Hmm.
Yeah.
Yeah.
So if you can say, I mean, can you give an approximation to the efficiencies of some of the main bows that are out there today?
No, I haven't tested many. I'll tell you when at the ATA a couple of years ago, I was talking to a guy at one of the booths, and he used to work for Elite. I think he told me Elite was happy at 85%. So I'm sure most bows are running there. Hoyt's probably a little higher. Bowtech's probably running in that 85%. I'd like to test the new the PSE because, like I said, my Omen with that S2 cam, it was up there. Um, Matthews, I haven't tested any arcs, but Matthews usually is pretty touching that 87% pretty much for the last few years.
Yeah. Yeah.
Hmm.
Yeah, that's some interesting stuff, the efficiency. So, now let's get into, I guess, kinetic energy and
Okay.
so explain to me again well, I guess start from the beginning. I know you'd made a short video series on this. What goes into measuring kinetic energy? Because I know when I'm talking to guys and you see videos online, people talking about kinetic energy in their arrows. What actually is it? How's it measured? And what factor does it play in, I guess, penetration and speed and stuff like that?
Well, we're going to measure kinetic energy by taking the velocity of the arrow and its mass. There's an easy equation out there for imperial. It's zero point 0.5 times the mass, which is in grains, times the velocity squared, and then you divide it by 225,218. Some people will leave the zero point 0.5 off the front, and then they'll divide it by what is it 450,436. So same equation. It's the same deal. The constant number comes from you have to turn grains into pounds, so it's 7,000, and then it's the gravity. So it's 7,000 times 32.174, and that's where you come up with that 225,218 number. And that's just how we calculate everything. You can do it in metrics. I don't do metric very well, so I guess that's the good thing about being an American. Actually, truthfully, when I'm doing a lot of equations, I actually convert over into metric because metric is a whole lot easier to work. And
Yes.
then I'll convert back when I'm talking to people. But kinetic energy, that's how we measure it. For penetration, there's two things you got to look at when it comes to penetration. If we're looking at physics only and we're not looking at broadheads and stuff like that. It takes kinetic energy and momentum both for penetration. Um, an easy way to probably say it, and it's not going to be 100% correct, so there's some physicists probably going to throw a fit, but kinetic energy basically controls the depth of penetration. Momentum controls how well that energy is used. So if you take two arrows with the same amount of kinetic energy, the one with the higher momentum is going to has the higher probability of penetration. Because if you slow the deceleration rate down by increasing the mass, you're using that same amount of energy more efficiently. So you can see a probable more an increase in penetration, and that's just physics. And I think that's where people over the years have gotten confused, and they want to use momentum as saying momentum's what causes penetration. It's not going to tell you kinetic energy has nothing to do with it. What happened is over the years, people testing, they matched the KE, and the heavier arrow out penetrated with more momentum. So they immediately said, well, it's momentum, not KE. Well, all it is the momentum used that energy more efficiently. So
Okay.
to be able to, another way of looking at it is to cut, break, slice, it doesn't matter. Anything to do work requires energy. Momentum is not energy.
Now, work is a scientific term, right? There's a
It's physics term. It's actually the equation would be the change of energy. And then you divide that by the displacement or distance, the amount of penetration, and that'll give you the amount of work that's done.
okay. So
Mm.
so that's a good
And actually, I
explanation.
did that wrong. It's actually you take no, that's right. Yeah. Change the kinetic energy. So you would take your like if you was to be able to measure in an animal or in an animal where your arrow stops, it's easy. If you hit it with 80 foot-pounds of kinetic energy and it stopped, well, then you got 80 foot-pounds of kinetic energy, and then you divide it by the displacement. If it came out of the other side and you had a way to measure that and you hit it at 80 and it came out with 40, then you would take your 80 and minus 40, so you'd have 40 divided by the displacement. And what you're looking at is the amount of work that's being done. And that's what controls all that is just resistance. You know, a lot of people freak out over testing in ballistic gel and stuff like that. It can be done. You just got to know what you're looking at. Most of the time when you're doing ballistic gel and stuff, you're just looking at the amount of force that was applied to the arrow. It's a real good test for testing broadheads. You know, you'll be able to tell, you know, if broadhead A or broadhead B, if broadhead A is penetrating deeper than broadhead B, well, broadhead A has less resistance being applied to it, so or less force. So that's a probability of a higher penetrating broadhead. So there's ways to test with that. You just got to know how to do it.
So that's a good explanation. Let's do you got any good examples? So let's take a 350 grain arrow shot out of bow A at 70 pounds, and then a 500 grain arrow shot out of bow A at 70 pounds. What's going to be the difference in kinetic energy there? Which arrow is going to have more kinetic energy?
Depending on the bow, they'll be within 5%, 3% of each other.
So that's
So
where the efficiency comes into play, right?
yes, yep. So there's
Okay.
not a whole lot of change there. What you're looking at is the how well can that energy be utilized, and that's where momentum comes in. That's why you look at momentum. You know, the problem is a lot of people they'll say that it's not relevant. If your arrow at 350 grains blowing through the deer, why do we need a 550? You know, if the 350 is not making it through the deer, then I would look at a broadhead first. You know, make sure you're not just burning all your energy up there. And if you're not, then increase your arrow mass.
So I guess what a lot of guys, or maybe not a lot of guys, but I've heard some guys, do tests, and these tests may be flawed or maybe they're not. I'm not sure, but they say that a heavy arrow won't, or I guess so many guys believe that a heavy arrow is going to penetrate farther. Is that true, and why?
If you're talking about an animal, the probability of the heavy arrow out penetrating, absolutely. Now, it may not be enough that it matters. You know, if like I said, if your lighter arrow is coming out the other side, then what does it matter? But if you're not getting the penetration and you're already using a broadhead that you want to use, yeah, you can increase the mass. Now, you're actually better to increase the KE of the lighter arrow, and you'll actually gain more penetration than you would just by increasing mass. But most people are not going to be able to do that, unless you buy a new bow or crank it up.
So,
So
so in my mind, and I think remembering back to one of our past conversations, increasing kinetic energy is always going to, or in most cases, going to outweigh the extra momentum. And tell me if I'm wrong here after I say this, but and that's why upping your bow a couple pounds is gonna benefit you a lot more than say shooting a heavier arrow. Is that at all correct?
it's close. Anytime you increase your KE, you're going to increase momentum. They both move. Now, your KE is going to be it's velocity squared, so it's going to be higher. But so it'll be. Can you do math in my head anymore? So you'll have a greater amount of kinetic energy. Momentum moves equally with either velocity or mass. So if you add 10% in velocity, you're going to get a 10% gain in momentum. If you add 10% velocity, it's around 40 something percent in KE. So yes, you're going to increase penetration by doing that. The only time that you really got to worry about things is when you hit a bone, a hard bone or a big bone. Now you have impulse. That's where the heavy arrow from the same bow really shines over a lighter arrow. Is when you hit a bone, you have an impulse. You're going to have a spike in energy burn. So you're going to utilize energy. So a heavier arrow, because it is moving slower and has more momentum, you're not going to burn as much energy. An example would be, and these are just arbitrary numbers. If I take a light arrow and I hit a bone at say 70 foot-pounds, and I hit a bone with a heavy arrow at 70 foot-pounds, that lighter arrow may burn 30, 40% of that KE up just trying to break that bone. That heavy arrow may only burn 20%. So once it gets through the bone, you got more KE left in the heavier arrow. So it's going to penetrate. It's still using the kinetic energy. It's just there's more left over. That's the advantage of that. Now,
Yeah.
people that are shooting, after you got a certain amount of KE, you're going to break a bone. It ain't going to matter. Just don't worry about the mass. You've got enough to break it. If you don't have enough to break it, then you got to do something to break it, which means either add mass or increase your KE.
So, yeah, the way you just explained that finally made sense in my head how that works. So, what kind of equates in my head to how you explained that earlier is, if I'm in the barn and I'm pounding a post or something in the ground maybe, and I take a lightweight hammer, I can swing it a lot faster, but it doesn't drive the post in very far compared to a sledgehammer that I can't swing quite as fast, but it's got more momentum to it and it drives the post a lot deeper. Because that transmission is like somewhat similar to breaking a bone, it's like an instant contact. Is that at all?
Yeah. When you're hitting a bone, like I said, you got that impulse. You got to be able to hit that bone and break it. It still takes energy to break, and I don't. That's the big thing. It doesn't matter. You got to be able to do work. So to break that bone, you got to have an energy. I don't care how much momentum you got. If you don't have enough energy, you're not going to break that bone. Okay. Where the advantage is that heavy arrow is going to have more momentum, so its deceleration rate is going to be slower. So again, when you hit that bone, once you push that bone far enough to fracture it and cause it to break, what the energy you got left over is what you're going to penetrate with. A lighter arrow is going to burn that energy up, where the heavy arrow is not going to burn as much. So so the heavy arrow will have more energy left over. With that more energy left over, you've got more energy to use. So again, energy is what you want, is what you need to look at, but that momentum is what's keeping that there. And that's probably a horrible way of saying that. The things to remember is when there's a certain amount of resistance force being applied back on that arrow, that resistance force is trying to stop that arrow. When that resistance force stops that arrow no longer has any kinetic energy. It stops. Once it runs out of energy, that arrow stops, no matter what. Okay. So you can take a heavy arrow with as much momentum as you want. If you got a huge broadhead on the front of it that is burning that energy up, it's going to stop. Okay. Take a lighter arrow, put a small broadhead on it, and it'll go right on through if you can decrease the resistance. Uh, Ashby was probably fantastic for showing that. Ashby showed that the geometry shapes of broadheads make a world of difference in penetration. So if you got a broadhead that's like this and you're having penetration problems, go to a broadhead like this and you're going to decrease the amount of resistance being applied to that arrow. It'll penetrate better. So that's things that. So Ashby was great for that. His physics were a little off, but it is what it is. One day, all of that will all get worked out, and we'll be talking more about kinetic energy and momentum, and not just momentum.
Yeah.
So,
Okay. So, equating this into choosing an arrow setup and possibly more importantly, a broadhead setup, I picture, just like you were saying, to be able to, I guess, do work on a animal that you shoot, and transfer that work into, a cut. You talk about a medium weight arrow that has a small broadhead and, blows a hole straight through the deer, and then, maybe it burns 40 foot-pounds of kinetic energy through the deer and then exits with 40. Well, that's, in my mind, that's 40 pounds wasted going into the dirt behind the deer, instead of, upping that broadhead size just a little bit to where, maybe now you're burning through the deer with, 75 foot-pounds of energy and then coming out the backside with 5 foot-pounds. That would be, is that more optimal? Is that...
in my head, yes. So back in 2021, I actually wrote a paper about that with Dave Holt. I had a lot of people trash me over that because I'm a firm believer in that. If you're using a broadhead and your arrow is blowing through there and you're 20, 30 yards past, you're wasting a ton of energy. Increase that broadhead, make a bigger cut, let the arrow fall out the other side. Why cut with a 1-inch when I can cut with a 2-inch? 2-inch hole is going to give you a whole lot more blood than a 1-inch. So absolutely, burn that energy up.
Now, there's also, the factor that a 2-inch broadhead can't get in between the ribs as easily as a 1-inch or something to that effect, or can't break through a shoulder blade. How does that fall into the equation?
You got enough energy, it'll break it.
Okay.
It'll break it. That again, that's where the broadheads that look like a Christmas tree, they'll slide through the ribs a whole lot easier than one that's real wide. But again, if you're running 40 foot-pounds of kinetic energy at impact, now that is something else most people don't think about. The kinetic energy at the bow, we use it for calculations. If we're looking for what we need at the animal, you should be looking at the kinetic energy at impact. Okay, so the rest of it, who cares? Once we're hunting, we need to care what it's in there. So if you got an arrow at 40 foot-pounds of KE, a wide broadhead may not be the way to go. So you just narrow your broadhead. But if you're hitting that animal at 80 foot-pounds of kinetic energy, if the broadhead will hold together, you'll shove it through there. So, oh yeah. It's kind of like bison. Now, bison are not a hard animal to kill. They're big, but they're not as big as what people really think, thick wise. Now, of course, I've only killed one that weighed roughly 1,000 pounds. I've killed a couple of them.
Only 1,000 pounds.
Yeah. So, but I was on a hunt. I was actually aoudad hunting. I had a 300 and I don't remember 380, 390 grain arrow. I was shooting a trifecta mechanical broadhead. I'm hunting for aoudad. I don't need anything. And a guy called me and said that they had a cow sitting over here that they had just shot the bull. She didn't run off. He said, "You want her?" And I said, "Yeah, come get me." So we got over there. She was moving around. I'm moving. And I hit her a little high. But that light arrow with that mechanical broadhead, I buried it to the fletching. She ran out there 80 yards and had blood all over the place, and she was dead. So, it did exactly what I needed it to do. Did I need a 650 to do that? No. but I wasn't shooting her at the leg either. You know,
Mm-hmm.
so yeah, I killed a water buffalo years ago with, I don't know, she was probably 1,200 pounds maybe. Um, I did that with a 450 grain arrow with a stinger broadhead on the front of it. Did I get a pass through? No. Did I need it? No. She died right there. So it depends on what you're doing, what you're looking for. You know, whitetail deer. Now, you have to think about whitetail deer too, because where I hunt, a big buck, 130, 140 pounds. You know, up north, that's not even their fawns. You know, so
Mm-hmm.
what we can get away with here may be harder to get away with up there. You know,
Yeah.
but still, you know, whitetail deer. If you're not in that damn, if excuse me, if you stay off that front leg, get back just a little bit, keep it in the lungs, right behind the heart in the lungs. It don't take much to get through a whitetail deer, even a big whitetail deer.
Yeah.
So,
Yeah. So, I guess going back to the, 400, 350 grain versus 650 grains, we talked about the efficiency that the bow is going to have. So it's going to be a little bit more efficient with that heavy arrow. You said somewhere around 5% or so.
yeah, depending on the bow, somewhere between let's say 4 and 5%.
Okay. So you're going to get a little bit more kinetic energy out of
Mm-hmm.
the heavy arrow,
Mm-hmm.
and you're also going to get more momentum.
Yes.
Now, we know it's 4 to 5% more kinetic energy, and then more momentum. How much more is that? And I guess what's the significance of it? For every 100 grains heavier you go, your pin gap gets
Mm-hmm.
X amount wider. But how much are you gaining on the penetration into things?
If you're a hunter like me, it doesn't really matter. I hunt 20 yards. You know, I'm in Texas, so I can hunt under a feeder if I want. You know, so you know, if I want to hunt 1,000 grain arrow, I'm at 20 yards. If I'm shooting, you know, 30, 40, 50 yards, I'm probably not going to shoot a 650 grain arrow. You know, because the con to a heavy arrow is time and flight. A lot of people say, or they'll tell you that time and flight doesn't matter. I did that test. I built a drop test that I do. It's a gravity drop test that I shoot off of my shooting machine. It's all PLC controlled. I tested two arrows at 30 yards. The faster arrow was leaving the bow at 292 feet per second. The heavier arrow was at 232 feet per second. So I'm reaching the target at 30 yards at 0.32 seconds with the faster arrow, 0.399 with the heavy arrow. So based off of sound travel and then the time that I used based off of studying I've done, I set a timer to drop the target. The faster arrow, I was seeing about a 2.8 inch increase from no drop to max drop. The heavy arrow, and I don't want to really say heavy arrow because it's based off of velocity. The slower arrow, because you can have a light arrow that's slow. I
Mm-hmm.
was seeing 7 inches. So even at 30 yards, the heavier arrow, again, the slower arrow, if you were shooting in the center of a kill zone, 8 inch kill zone, you're out of the kill zone. You know, now at 20 yards, you're still in the kill zone. So distance makes a big difference, and when you're shooting slower, you need to get closer. You know, there's a lot of talk back and forth about that, about sound. Is it the arrow? Is it the shot of the bow? Most of the time, it's not the arrow they're hearing; it's the shot. And what happens is people see that and they think that the animal doesn't react till the arrow's halfway there. Well, you got time from the shot. So at 30 yards, it takes about 0.08 seconds before the sound reaches that deer. So that means that arrow's already traveled 0.08 seconds. The reaction time of that deer is a fast one is at reacting at 0.1 second. So now we're at 180 milliseconds or 0.18 seconds. So that's when the deer starts to react. So now if you got an arrow, and I'm gonna have to do some math here, I'm gonna use cheat. So if you take an arrow that's traveling at say 0.4 seconds to reach 30 yards, man, well, let's just do 200. That's still 200, so that'd be 220 milliseconds that animal has time to still move before the arrow gets there. So what happens is the arrow's already traveled and it's halfway, and then the animal starts moving. Well, they think that it's because they're hearing that arrow coming. And I'm not saying they're not correct. Right now, with my testing I'm seeing, I'm going to tell you what it is they're hearing that arrow being, or that bow being shot. It takes that long for them to react. So the arrow's halfway there. So when that animal starts moving, they think they're hearing the arrow, and it's not. It's just the delay in reaction from the bow being shot. That's a horrible way of saying that, isn't it? Uh, that's the reason I like to write, because when I'm writing things, I can look at it and realize how stupid I sound. So I can rewrite it. But that's
Well, that being said, though, tell me about your website real quick.
so
You've
I got a website, pnltesters.com, and I've got some of that data that I did. It shows you for that velocity test. I did it with, I joined a group called Technical Archery Research Group. We call it TARG. We did a study down here in Texas back in April. I'm gonna say we did a study. We didn't even break the surface of what we wanted to do. I told the guys, pick 10 things you want to test. We'll be lucky to do two. We didn't even get two done. There's just not enough time. I've already had people come at me about, oh, you went out there and you were going to prove all this. And I told them, I said, it took Ashby 30 years, and you expect us to do it in 4 days? Yeah, so we just started scratching the surface. Um, but that's what I did is I tested all that only at 30 yards for now. I need to back up, do it at 20, 30, 40, and 50 yards. But I can set times, I can calculate all that up, and I can control that drop of that target. It's a gravity fed target. I just set it up, set it top, and I turn the magnets loose, and it free falls. So it was a pretty good test. It at 30 yards, I didn't expect the slower arrow to have a 7-inch drop. I figured it'd be a little less than that, but so um, I saw, I don't remember the guy's name, Scientific something on YouTube the other day, and he actually calculated a bunch of stuff, just calculating, and his numbers are actually pretty close to what my actual field test looked like.
yeah,
Hmm. Hmm.
yeah.
So,
Yeah, and all this data, or at least some of it is on your website, right? And
yes. Now, it's funny you talk about it. I have written probably, I don't know, a couple of hundred a couple of hundred papers. I probably got less than 1% of my papers are even on the web page. Um, some of them papers I don't even finish. I get through them, I go through them, and there's something I don't like, or I change my mind. I just drop them, which is horrible because I got one paper that I was working with a physicist out of Belgium. We got almost 100 hours tied up in that paper, and we just stopped.
yeah,
Yeah. Um,
wow,
yeah, I look at time as money. So I know how much money I charge when I'm here working on people's equipment. If I cut that in half, and then I look at that paper I spent 100 hours on, I lost $10,000. So some people don't look at it that way. I always look at everything with money. Is it worth doing? Most of the time when we're testing and we're doing that, it's not worth doing. I just enjoy doing it. So,
yeah,
mhm.
yeah, yeah. I mean, well, that's a big part of it. I mean, I can definitely tell you enjoy doing it, and
Oh
you're
yeah.
very good at what you do, I think. But yeah, that's some interesting stuff. So, and then we talked about like the kinetic energy and some of that
Mhm.
stuff earlier. I know you came out with some videos there, just short videos explaining in basic terms what each of those things are, and I think that's going to help some guys understand more of the physics end of things and how these different things relate to each other. But yeah, so I
Yeah.
think
Yeah. I'm sorry. Yeah. I did mass and weight first. Because people don't understand that there's a difference between mass and weight. So I did that one first, and that was just for me to learn how to make shorts because I had no clue. So I've gotten better. My second set of series I'm working on right now is for Newtonian physics or Newtonian mechanics. So that's the one I'm working on now. The shorts are a little long. Thank goodness YouTube allows, I think, 3 minutes because I'm over 2 minutes on some of the shorts, which probably means nobody's going to watch. you know, so if they're like me, they're not going to watch. My attention span's pretty short.
well, I tell you, they're a lot easier to watch than I guess Bill Nye the Science Guy because he's explaining it in kilograms and meters and stuff like that, and you're explaining it in feet per second and grains. Just that right there makes it way easier for me to understand. But
Oh yeah, me too. Me too. So yeah, I hate trying to convert grains into kilogram. It's
yeah,
easy to count, but yeah, you don't. We're used to looking at a 450 grain arrow, whatever that is in kilograms. It's a pretty small number, so it doesn't compute in my head very well. So, mhm.
yeah, yeah. So I guess back to the application of a
Okay.
lot of this stuff. Choosing. I guess there's always been so many debates on choosing arrows for arrow weight and stuff like that. And then we talked about broadheads, broadhead diameter. Let's talk about FOC. What
Okay.
is FOC, and how does it affect the flight of an arrow, the impact of an arrow? What's the correlation there?
So FOC and how we measure it, we're doing is we're just measuring based off the center to where the location of the center of gravity is, or center of mass. Some people say mass or gravity, same thing. It's not the same, but we can interming it. So, um,
And what is front of
so
center, right? That's what it stands for, FOC.
yes, front of center. What they're doing is you just take a balance point, say so, and then you measure the length, find your center, and then you found that difference. And there's a calculation you do, and it'll tell you, what it is. So a 30-inch arrow, if your balance point is at 18 inches and your center is 15, that's 3 inches. So that'll give you a FOC of 10%. Okay. Um, that's just a reference number. There's more to it. Um, FOC is about aero stabilization. It's about flight. It's not so much about penetration. It's about flight. So there's several numbers to look at. You look at I call center of gravity. You got a number back here. This a place that's called a center of pressure. This is where all the forces are acted on to make corrections. In between that point, it's called the static margin. That's what's important, because you can have a low FOC, but if your center of pressure is back here and your static margin is right, you still got a good stable flight. Okay, that's why you'll see people take fletchings. They'll increase the fletchings. Um, they'll increase them, move them around, and what they're doing is they'll tell you FOC don't matter, but what they're truly doing is moving that center of pressure, so they're making that static margin larger, and that's the key, that static margin. So for us, I still like building arrow weight with my FOC or tip weight. Just shove it up there. It's not really so much about the FOC about that. That's how I just build my weight. It's more stable. But you don't need anything over 18, 20%. Will it hurt? No. I've hunted with 30%. Matter of fact, because I'm short, I took a Bowtech Reckoning with a 7-inch brace. I took my rest. I drove it as far back as I could get. I built it like a 24-inch arrow, and I took it to 29.5% FOC. It was right under 500 grains, just right at 500 grains. But, FOC is about stabilization. So if you've got an arrow that's flying horribly, you're going to kill penetration. Okay, because now you're not hitting square, you're hitting sideways. So now you've lost the energy there. Increase that FOC or whatever to get you good flight. You'll increase penetration. A lot of people will claim that they did that because of FOC. Well, the FOC by itself is not what increased penetration. Your FOC corrected your flight. Because you had better flight, you increased your penetration.
So, are there any advantages to not having a high FOC?
Yes. Certain broadheads have too much lift. So if you get a broadhead that's got a lot of lift, it's trying to steer. So you'll get a erratic flight. So what you do is you can increase that FOC, and what you're doing is put more leverage at the back end, and it allows the back end to control that broadhead, and you'll straighten it out. You'll see a lot of that when somebody's they'll tell you broadhead A flies great, broadhead B flies horrible, and they'll even tell you bare shaft tuned, bare shaft tuned. So, but you'll ask them, well, what's your FOC? And they'll say, oh, it's 10%. Well, increase your FOC, drive it up there about to 15%, and watch what happens with broadhead B. It'll start correcting itself. It'll straighten out. So
So, so when it comes to having an arrow that corrects and has better stability, so if your bow's not tuned or you make a bad shot and that arrow's going down there crooked, for it to correct faster, you need to have some combination of higher FOC or a center of pressure that's farther away from the center of gravity.
Yes, increase your static margin. So yes, absolutely.
Static margin, that's what that's called.
That is one way. You can spin an arrow faster and do the same thing.
Really?
Oh yeah. So I did a test for fletch, and I did it on the Quad X, and I built a 1 degree, 3 degree, and a 5 degree. That 5 degree corrected extremely fast.
Really?
Extremely fast. Yes.
Is that because the center of pressure is farther back or because it's rotating faster?
I'm going to say it was rotating because I built them identical. So I had 3 arrows. They're all identical. The only thing I changed was the rotation. So the rotation had to have been what was correcting that arrow faster. I did kind of like what Yates and them did. I did mine back in like February 2025. I forced a tear. And I'll tell you, the 1 degree, I forced it to a little over a 1 inch, I think, and I'm talking at 4 feet. Or I'm sorry, 4 yards. The 5 degree, 3/4 of a tear, it was massively different. So,
wow.
A lot of people will talk about, you spin an arrow too fast, you'll see a parachute effect, because it's slowing down faster. Now I only tested the 60 yards because I was only testing for shooting the arrows for 3D. So I went 10 yards past 50. Yes, I lost less speed with the 1 degree, but it was like 9.14% loss with the 1 degree, and it was like 9.44% with the 5 degree. It's not, now what happens at 100 yards? I don't know. I didn't test. It's hard to test out at that kind of distance because the lab radar, at about 60 yards, well, actually about 40 yards, the data it collects starts going to crap. So you really, really got to do a lot of working to collect good data. Even at 60 yards, I had to take 40 shots. So yeah, because I look at if you'll take the memory card that's in a lab radar, pull it out, put it on your computer, you can look at everything. It'll show you the time in flight, the distance. It'll show you what the signal to noise ratio. So if that signal to noise ratio starts getting low, your measurements start getting really sporadic. So you have to take a lot of shots once you get out there at around 40 yards and on. You got to really do that. At 100 yards, it's all over the place. So
yeah,
I stick at 60 yards, and don't worry about anything else. Not for trying to collect speed.
Okay, so you said a couple big pieces of information there. One of them is FOC. So is there any reason to let's talk about how do you increase your FOC. There's a couple things you can do, right? Increase point weight and decrease shaft weight and fletching weight and all that, right?
Yes.
Okay.
Yes.
So, so to increase FOC, you go with a lighter shaft and a heavier point to meet your, whatever weight arrow you like to shoot, 450 grains, call it. And then you can also get bigger vanes, right? Because that's going to move that center of pressure farther back.
Yep.
On the arrow.
Or increase your count. We'll do the same thing. Go from a 3 to a 4 fletch.
Yes. And in my head, if I'm going to, I think about it this way. So when I'm fletching up my vanes, I like to draw the bow back and see how far back I can get those vanes on the arrow before they get face contact. And that's where I fletch vanes, trying to get them as far back as possible to bring that center of pressure farther back. So in my mind, a 4 fletch of 1.5 inch vanes is going to sit farther back on the shaft versus a 3 fletch of 2-inch vanes. Now there's still a total of 6 inches between those two arrow steps, 6 inches of vanes, but with the 4 fletch, you're sitting farther back on the shaft. So which one's going to provide you with a I guess a center of pressure that's going to be farther back. In my mind, it's the four fletch, but
It
I don't really
the
know.
unless you're shooting a three fletch, it's really big. The four fletch is going to probably do a better job for you. Um, so the good thing about a four fletch also is your degree of helical offset. You can use less with a four fletch and get the same outcome as you do with a three fletch that require more. Again, arbitrary number. Let's say a three fletch. I set it at 4 degrees, but a four fletch I may only need 3 degrees and get the same outcome. So there's a lot to it. When you're increasing mass, so you got up on the front, you got to remember spine is very, very important to understand. And some arrows manufacturers cannot handle the same. You take a 300 spine from one brand versus another, one of them may handle, say, 300 grains on the front, the other one may not be able to handle it. So that's some of the things you got to really, really watch for. So it's
Yeah.
very important. Yeah. Spine's really important. Straightness is okay, but it's not near as important as spine.
Okay. Okay. Yeah. So, okay. So back to episode. So I need to get a lighter shaft weight. And when I go to a lighter shaft to meet my total arrow weight, I need to put more weight in the point. And then, three fletch versus four fletch, that's been another big debate. Sounds like you're on the four fletch side of things.
I four fletch. Well, I say that my hunting arrows right now has got three fletch. I've got Pro 2.5s on them. If I'm hunting with my Quad X, I do four fletch.
Okay.
So,
So, so why not five fletch or six fletch?
you can. I did a arrow for tack. I used a Fletch Flex 1.87, little bitty vein. I had
Yep.
some that I had from them. Now I don't remember the helical. I probably still set my jig at 5 degrees. You're just not going to get it out of it's there, but it doesn't look like it. I did it in a 6 fletch. That arrow was a dart, and then I lost it. So, you know how it is. I'm
Yeah.
not a long distance shooter, but that arrow it flew great. Now I don't know what it would do with a broadhead. I have no clue. A mechanical would probably find a broadhead that doesn't have a lot of lift. It would probably do fine. I probably wouldn't want to shoot a 2 inch wide monolithic broadhead or a fixed broadhead. I probably wouldn't shoot a 2 inch with it. But an inch broadhead, oh yeah, I'd have shot with it all day long.
Yeah. Okay. So, okay. So on the veins, I mean, I guess what's the argument for three fletch? Because as far as what I see, three fletch is still the dominant fletching configuration. Why are guys still shooting that when, data like this points more towards a 4, 5, 6 fletch?
Because people are taught if you increase fletch count or if you increase the helical offset, you're increasing drag. So by increasing drag, they're worried about a parachute effect. And it will happen. It can happen. But right now,
what
go
is a
ahead.
parachute effect?
Parachute effects, all it is once an arrow comes up to a spin rate, that spin rate pretty much stays there. So as that arrow's in the flight, you're decreasing velocity. So what happens to you, you'll reach a point that the forward movement of that arrow is slower than that speed rate. There's actually a ratio, and I don't remember how to calculate it. That ratio, once it gets below that, that arrow will go unstable. You'll start seeing the back end of that arrow start doing that. And you just went unstable. So if you're shooting that far and you got an arrow doing that, you just increase your FOC, or if you don't want to change weight, decrease your helical offset, and you'll start straighten some of that out. But at 60 yards, I'm not seeing it at all. So, and even at tack, shooting at 100 yards, I'm not seeing it. And I fletch everything right now, everything at 5 degrees, everything.
Really?
Whether I do 3 or 4 fletch, everything's at 5 degrees.
Yeah. That's really interesting, because that's, and I guess that's always what's kind of made sense to me in my head. But then, then you go into the target world and you've got guys talking about, this magical factor of forgiveness and how that can play a part in fletching configuration. There's, I've talked to several people myself, and I've done it too. Tried different fletching configurations and found out what was most forgiving. And, that's something that, the forgiveness factor, that's something that I think is for the most part, like unknown. Because in a lot of cases, and like this one, it can contradict the data. When you're talking about the parachute effect and stuff like that. So that's an interesting topic, and maybe a topic for the next episode. But so you also talked about testing spine and straightness. Um, let's start with straightness. What is straightness? How's it measured? And does it matter?
It matters some. I'll tell you, manufacturers may be testing it, but none of us are testing it correctly. Period. Because when you test for straightness of an arrow, there's supposed to be zero contact. We're all hanging away, and we all got an indicator sitting on it, and we're checking run out. It is not. There's supposed to be zero contact. Um, so what happens to you once we hang that weight, or even if we don't hang a weight, we just stick it on there and we do it without a weight on it, we still got contact. A stem on a indicator applies about 21 grams of weight, somewhere between 19 and 21 grams. So you're already putting pressure. So if the arrow's got just a little bit of a bend, or a little bend in it, when you put enough pressure on it, it may show zero when actually it's got one or two thousandths run out. So we're not quite testing right. Does that really matter? No. I doubt if any of us, you might, because how you shoot, your pros, they may see a 5 to 6 total indicator run out. Me, most of the people like I hunt and stuff, even shooting longer distance, we can't tell the difference at a 12 thousandths run out. Tune the arrow, knock tune it, and go. You're not going to see it. There's a guy, golly, I just went blank too. Rick McKinney. I don't remember the arrows company he has or had. I don't know if he's still there. He wrote an article about that years ago. And even in their trad bow out to 50 yards, he said anything up to .005, they couldn't tell. So is it that important? Maybe, but not for me. Not for the most average person. Spine is way more important.
Okay,
way more important.
So talk about that. How is spine measured? And are you measuring? I guess the ram spine tester is like 28 inches with a like 0.3. I don't even know how much the weight weighs that hangs in the middle, and then you measure with the dial indicator.
Yes.
Is that how spine is tested all around, or are there other ways to test it?
Yeah, probably other ways. The standard is that way. A 28-inch span, you use an 880 gram weight, put it in the middle, put an indicator on it. Now, when I'm testing my indicators, I pull the springs out of them because that spring changes that pressure. So if you're not in this, the more you push down on it, the more pressure that spring's applying. So as you hang your weight, guess what happens? That pressure starts changing. So I remove my spring. Okay, and then I mathematically take that out of it. So when I'm testing for spine, I mathematically take that weight out. If not, that arrow is going to look weaker than it really is.
Yeah.
If you follow the ASTM standard, you're supposed to read 4 places. I read 4 to 8 places depending on what I'm doing. And it's just around a shaft. You hang the weight, take your measurement. I take the weight back off. I rotate it 45 degrees. Make sure my indicator's at 0, because it may not be at 0 when you rotate it around, because if it's not straight, you're going to change that indicator. Read 0 and hang the weight on it again. And then I'll plot that arrow that way. There are other ways of doing it. I'm looking at, and I may or may not build a tester that I'll actually hang a weight, and then I'll be able to put a certain amount of force on it, and then I'm going to be able to record with a program and actually rotate that arrow and see what that arrow looks like. What that'll do for you is these arrows that are claiming that they got 0 spine, I'll be able to see if that's true or not with that, because I'm going to put some weight on it. Most arrows, when you're testing like that, we're hanging an 880 gram weight. Pull on it. Instead of hanging that weight and you rotate it and you don't feel nothing, pull on that weight. Put about 5 pounds worth of force on it, and a lot of them arrows that they're saying has no spine, you'll find it. Okay? Does that really matter when you're shooting one out of the bow? Probably not. Probably not. It's not as critical as people think. Personally, I think an arrow that has a spine so that I have to knock tune is better than one without. Okay? And the reason is if I can control how that arrow is reacting when I shoot it, then I can repeat. If I pull it, if I force an arrow, if I tune an arrow to come out of the bow, say knock high, knock right, and every one of them are that way. If I don't do something correct, then what happens to me is I may not be as much, but I can still force that arrow the same way. If you take an arrow that has zero spine, if I turn it, I may come out one way this way, and the next time it may come out this way. So I've got no control of that. So
That's
I
yeah,
yeah.
that's really interesting that you say that. And I guess what equates to my head is if you look at some of the top 50-meter shooters right now, so the compound guys that are running like the World Cups and stuff like that, shooting World Archery. I think that at least a couple of the top ones that I've heard of, talked to, they've been running their arrows to kick. I can't remember what the paper tune would be, if it would be knock left or knock right. But I know that the bear shaft, a couple of them have been making their bear shafts impact, that much to the left at 50 meters, and and that's one of those things where those guys are group tuning, so they're just tweaking the rest just a little bit and seeing what's the most forgiving. And when you explain it that way, that could put an explanation as to why having that bear shaft or that paper tune a little bit out to the left could be more forgiving, just because you're influencing it that one direction and it's repeatable, instead of trying to go straight down the middle. But inherently, it might be slightly to the left on this arrow and slightly to the right on the other one. But that makes a good point. I know, I think it's George Riles that explains, why he puts, he likes a lot of weight on the one side of his riser. He pictures a, you take like a big plate that like the waiter would bring you your food on, and you put a marble on it, and imagine walking around trying to keep the marble in the center of the plate. It's going to be moving all over the place. Or you could tip the plate to the side and put the marble up against the side of the tray and hold it dead still as you go and walk. Same thing with like the weight on your bow. And then you can even, maybe even bring that over into tuning your arrows as well. But yeah, I think I heard that from George Riles in a video I saw recently. Right. But that's interesting. That's interesting.
Yeah. I probably wouldn't tune like that if I was shooting a big fixed broadhead, because you're trying to control steering. But for target or 3D, absolutely. Force a kick, force something that reacts the same every time.
Yeah.
So yeah,
that makes sense. So, and you talk about that, the differences in tuning and arrow flight when you've got a big broadhead on there versus a field point that has very minimal, I think lift is the right term. Yeah, that's really interesting. So that brings me to a question. I think it was last season. I was shooting some fixed blades, and I think I had won some fixed blades or something in a raffle, and I had about a half dozen of them that I wanted to use. And my particular arrow setup was shooting pretty fast, and it didn't have the biggest vanes on them. I will say it was probably like a 2-inch medium profile vane, so in a 3 fletch configuration, so not a ton of vane back there. But the smaller broadheads that I'd been shooting, they were these little 1-inch cut fixed blades, vented heads, and very minimal lift. And I could get those to shoot great groups at 20 yards, 30, all the way out to 60. And that's kind of where I stopped with them. And then I got this, 6-pack of heads that I got for free, and I wanted to shoot those for the season, try and use some of those up. So I went out in the yard, and I had a McKenzie deer target, and I had my bow all tuned to where those other fixed blades were hitting right next to my field points, and but I stepped up to like 15 yards close range. That way I knew it wasn't going to miss. And I shot these other heads that were maybe inch and eighth cut, maybe slightly bigger. And those broadheads like wind planed so much that at 15 yards, that arrow hit 3 feet off in the back leg of that deer target. I'm like, what in the world's happening? Did I not have my arrow on the rest? What happened? And so I shot it again, and same result, missed way off in whatever direction. Why is that? I mean, how can there be such a big difference in these different fixed blades? Is it the design? Is it one of them's just bigger than the other? What's your thoughts on that?
It's definitely the design, you know. And it's funny because you can take two broadheads that look the same, but have different lift. I can't, I've never studied enough to explain that, but two broadheads may not have the same amount of lift. So, and that's exactly probably what you saw. So either you didn't have enough vane on the back, or your FOC was kind of low. So that broadhead was steering. You never want the front of your arrow to steer. Never. I'm fixed to probably say something I shouldn't say. There's a couple of manufacturers out there right now that's got broadheads. They're pushing an issue that their design is to help steer the arrow. Okay, well, that's the craziest thing I ever heard in my life. You never want the front to steer. Okay.
Yeah, and that's because you want the center of pressure as far back on the arrow as possible, right, to get the most stability out of it.
Yeah, but you want the back end to be doing the steering, never the front. Okay, because if you got the front trying to steer one way and the back trying to steer a different way, you're never going to stabilize out. You're going to be all over the place.
It's like pushing a chain uphill, right?
Yeah. If the front was a better way to do it, then NASA'd be building rockets that were steering from the front, not the rear.
Yeah, that's a good point.
But so there's several manufacturers out there that are doing that, and that's wrong. I'm a firm believer if you're going to shoot a fixed broadhead, you want 15% minimum. Now, does that mean 10% would work? I'm not going to say it wouldn't, but why? Just go ahead and build it to 15%. Get it up there so you don't have to worry about it. Most people, it's funny, most people tell you they don't care what their FOC is, and they've never had an issue, but if they was to measure it, most of them are probably in that 15% range. So you're already inherently building the correct arrow, and then you're claiming it doesn't mean nothing. Well, you've already built it. Take that arrow down to 10%, watch what happens.
Yeah.
So yeah, so it's there's a lot of technical to it. Most people don't care, but usually if you got a tune set up and broadhead A flies good and broadhead B doesn't, that usually means something's going on with broadhead B. It's just steering. You just got to correct it or go back to the other broadhead, which is what most people do. Now velocity makes a difference in that too. Okay. People talk about how a broadhead wobbles, and they tell you never want one that spins bad because it causes all kind of flight problems. I used to hunt with Zwickeys. Of course, I was shooting 250 feet per second. I could take a Zwickey that would look like this when you spun the shaft. I never had a problem with it. Now, hit about 290 feet with that arrow, and now you got a problem. So there is some speed in there, but again, if you build the arrow right with the correct static margin and everything, you could shoot one with a fixed broadhead with, it ain't gonna matter, 350 feet per second. If it's built right. Problem is most people don't build them correctly.
Yeah.
So yeah.
Yeah, I know several guys that shoot a fixed blade broadhead at 350 feet per second, and it's insane. But I do know that they're making sure that those heads are on perfectly straight. They're doing the spinning like you're talking about, and doing all the stuff like that. And you probably do have to shoot a little bit bigger vane, to get that to be stable. But yeah, that makes sense. So and you talk about getting an FOC farther forward. And we said this earlier. You can have a lighter weight shaft. Why would somebody ever want to shoot a heavier weight shaft as opposed to a light shaft with a heavier point?
Just mass.
To get to a total arrow weight. And then probably durability is a factor too, right?
Oh, yeah. Yeah, your lightweight arrows they're going to be a little more brittle, than versus a heavier weight, if you're buying a 300 spine arrow that's a 7 grains per inch, and then you buy one that's 10 grains per inch, I promise you that 10 grain arrow is going to be a whole lot tougher. Some people don't care. If you break an arrow, you break an arrow. So some people worry about it, some people don't. If I
So
get my arrow back, I'm just happy. If I don't worry about it.
yeah. So I mean, other than shooting in your yard and breaking knocks and Robin Hood and arrows, like when you're shooting an animal, is there an advantage to having a tougher arrow versus a more brittle arrow? Like I've seen arrows break off inside animals and stuff like that. Is that a problem? Is that okay?
Mm, so I don't know. It depends on the person. As long as you're killing that animal, some people don't care what happens to the arrow. As long as you're reaching the other side, if they break it, they break it. If they don't, they don't. A lot of times, a lot of arrows, when an animal, if it don't pass all the way through, when that animal takes off, he breaks that arrow when he moves that leg. If it's a heavier, thicker base arrow or a tougher arrow, it may not break. You know, so you may get it back. We've all seen an animal fall, and you're over there, you're hollering at the animal fall the other way so it don't land on your arrow and break it. We've all done that, but it just depends on what you want. I think a lot of that's opinion, unless you're looking for mass. Personally for me, I want a decent arrow that's tough, but I want to build my mass with the front end.
Yeah.
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 So, I mean, roughly to get an arrow in I guess average is probably 450 grains, something like
Mm-hmm.
that. To get an arrow in that weight range, what would your arrow setup be like for a total arrow weight at 450?
I run my arrows short. So with my draw, as long as the broadhead will clear the riser, I'll pull within a half an inch, probably even a quarter of an inch to my rest. So I can easily shoot a shaft, depending on the brace height of a bow, 25 inches. So, and I'll do that all day long. As long as that broadhead will clear that riser, I'll drive it right up into that riser, right up into the rest. And what that does for me is that now I got a light arrow, and then when I add that weight back on the front, then I get back up to my whatever weight I want, and I've got plenty of FOC by doing it that way. Uh, I, the only time I run a long arrow, an arrow out in front of my riser, is if I'm shooting something that's really big. If a mechanical, I drive them all the way up in there. Fixed broadheads, it depends on the fix. If I can turn them, get them so that they'll pull in and clear, then I'll still pull them all the way. If they're going to be where I can't turn them, or they're big enough to touch that riser, then I'll run it out front. But if I can get away with it, I always cut my arrows right up to my rest, within a half an inch.
Yeah. Okay.
Mm-hmm.
So hunting species to species, as far as broadhead size goes, on a, I'm trying to think of a smaller critter, on like a white-tailed deer down there in Texas versus a moose. Are you
Mm-hmm.
using the same broadhead, different size broadheads? What's your thoughts there?
Depending on the broadhead, probably shoot the same broadhead.
Really?
Yeah, I am a fixed broadhead person. I do shoot mechanicals. I prefer fixed. It's just, I've always shot fixed broadheads.
You shoot fixed blade broadheads, single or double bevel, and you shoot the same head on a moose or a whitetail or anything.
Oh yeah, absolutely. I'm if I'm hunting, if I'm mainly hunting, I'm hunting with a fixed broadhead. I've been for the last few years. I've been shooting trifectas. They're single bevel. They do real good for me. Um, I wouldn't. I don't know. I might shoot a moose with a mechanical. It'd have to be a good mechanical, but I'd probably shoot one. I'd probably try to. I shoot 60 pounds. I'd probably work my way up to close to 70 pounds on my bow so that I could get a little more energy and momentum out of it. And then I still probably wouldn't hunt with more than a 450 grain arrow.
Yeah. Yeah.
I might bump to 490 maybe, but that would be max. Usually, I try to stay in that 6 to 7 grains per pound, but that's probably about right. Even at 60 pounds, I'm running pretty heavy because I'm running not quite 400, so 7. So I'm running about 6 point, 6.6 when I'm shooting
Yeah.
60 pound.
Yeah. Yeah.
Yeah.
Well, I guess that's pretty normal, I'd say. Like that's
I
nothing.
think so.
Yeah, nothing too wild, but yeah, so it sounds like with all the stuff that we've talked about today, it's almost like a spectrum, that a heavy arrow versus a light arrow, there's pros and cons to just about everything you look at. And I think that after, hearing what you've had to say today, I'm able to make a more educated decision on, which end of the spectrum I want to be on, or if I want to be in the middle, I think that's a good point. This has been a great conversation. I learned a lot, and I hope that, I know that everybody listening did too. But
Well, hope so. And like I said, there's a whole lot more we could talk about. We hadn't even scratched the surface.
oh
You
yeah,
know, and like on arrows, I'm not against heavy arrows at all. I've hunted all the way up to about 630 grains. My favorite broadhead, and they don't make it anymore, is a grizzly stick. Used to make a broadhead called the Nanook. It's either 300 or 350 grains. It looked like a spearhead. That is probably one of my most favorite broadheads. I got 3 of them that I'll never shoot. They're put up in a safe, and that's where they're going, because they don't make them anymore. So yeah, I've hunted all the way up to the 630 grain range, so a good average arrow up to probably 3 or 4 years ago was probably 525, but probably 3 or 4 years ago I dropped down, and like I said, I've been hunting between 380 and 410
yeah,
with the same results. So
yeah, with the same results, then yeah, why not?
why not?
Yeah, that's interesting. Well, yeah, this has been a great podcast, Eric. I think that if people want to go look at your data, they can check out your website. What is your website?
It's just pnltesters.com.
Okay, perfect.
Like I said, so what's that? I'm sorry.
They'll be able to find that. And then, do you have any social media or something where they can find you?
I got on Facebook. I don't get on it a lot. I do have a P&L Testers on Facebook as well. My main page is my name, so I'm on that one, and I don't do a whole lot of archery on my personal page. I'm usually political, so we'll stay right there. So I haven't been kicked off of Facebook in a while, so I guess I'm doing pretty good. But I do got that. I've got an Instagram. I'm not real good at Instagram because I use my PC, not my phone. So, and Instagram is not very PC friendly. I do got a YouTube channel that I've just started. So, I mean, it's just got a few things on it, just trying to learn how to do all of that. So, us old people have to really work hard at some of that.
Well, I think you're doing it well. I think, with all that out there, people will be able to find you, get a hold of you if they want. Thanks for coming on the show today. I think this has been a very good episode, and I feel like we could keep talking for another hour.
Oh, easy.
Yeah.
Like I said, we haven't even touched the surface yet. So,
well, you know what that means. We're gonna have to do another one, Eric.
Yes, sir. Yes, sir.
All right. Well, we'll see you on the next episode then.
All right. You be careful. Thank you.